So I decided to try to make a concept map of the experimental design. And in order to do that, first let's start off with some of the background that we had discussed in class. We talked about the properties of gases, and why did we talk about the properties of gases? The fact that they create pressure in a closed container, they form mixtures like air, that air is a mixture of gases, that they can chemically react and turn into, and as they chemically react, if they turn into a solid, then the pressure inside a container will decrease. We talked about examples. How do we know that gases produce pressure inside closed containers? And we talked about things like balloons and lungs. And another one that came to mind was a 2-liter soda bottle. You know that it's under pressure. But you open it and you release the gas. The gas leaves. You hear it shh as you unscrew the top. You see that the bottle has less pressure. It's not as firm. You know that. You've experienced that. So we talked about that because that's going to allow us to design our experiment, but we could not design our experiment unless we understood these facts as listed here and thought about these examples. So thinking about air as a mixture, the atmosphere as a mixture of gases, suggests that also allows us to know that the atmosphere causes pressure, rather a mixture of gases. The atmosphere then, being a mixture of gases, causes pressure on everything on Earth. Since the atmosphere is the gases that are on Earth, if gases produce pressure, and you think of the Earth as an enclosed container, then all that pressure is pushing down on everything on Earth. So at sea level, the atmospheric pressure is 1 atmosphere. And it takes a lot to change that atmospheric pressure, right? A little bit of steel wool in a test tube won't change that air pressure. Atmospheric pressure changes with weather systems, but that's pretty much the extent of it. So at sea level, atmospheric pressure is 1 atmosphere. All right. So that's some of the background. There was some other background information we went over. We went over that iron is a component of steel wool. So iron and carbon is steel, right? We went over that it reacts with oxygen to form iron oxide. In other words, things rust. And the examples we talked about: rusting, a car rusting, or iron in the blood turning red. It's not quite rust, but it's close. The iron is bonding the oxygen and taking it out of the air, out of the mixture, out of solution. So here you have your airtight container, just like we discussed. There's iron or steel wool. The air is trapped inside this container, creating pressure. It's pushing down on the water and the glass. The glass is stiff, it's a solid, so it's not going to move, but the liquid water can be pushed down, or if there's less pressure pushing down, could be pushed up. Pushed up by what? By the air pressure. The air pressure outside, the atmospheric pressure. The atmosphere is pushing down on the surface of the water outside, and then the water inside is being pushed by the gas inside the test tube. Obviously, in the beginning, they're equal because you see that the water line is even. All right. So based on that background, see, there was a background information there. Based on that background, we designed this apparatus, this system, to test it. We designed putting steel wool in here, the water level, the flat test tube. All that was designed. So then we had 2 groups. We had the experimental group, and then we had the negative control group. Let's take a look at the negative control group first. It's the comparison group. So then there is no iron in this particular group, right? And there's no iron in the negative control, but everything else is the same. We expect nothing to happen. whatever happens in the negative control happens in the present with the presence of oxygen. So if the water level in the test tube goes up when there's no steel wool, then when there is no steel wool, if the water level inside the test tube goes up, then it has to be something else going on. It can't be the removal of oxygen because nothing removed the oxygen. So if the water level changes, then the water level changes because of some other reason, not the loss of oxygen. All right, let's leave the thinking, the little cloud thinking, the purple line there for last here in our thought map. If we take a look at the experimental group, we know we have iron. We add iron to remove the oxygen, so the iron in the steel wool is added to remove the oxygen by producing iron oxide, or rust. And as the oxygen is used up to make rust, there will be less pressure because there's less gas. The atmospheric pressure is fairly constant, as we discussed earlier in the background. So that experimental group allows us to really think about what the results mean. So we know that we're going to have results. That's our evidence. We made a claim, and now we're explaining this sequence of ideas helps explain our reasoning. So let's take a look. And so this is our thought. This is our reasoning based on all that, based on the background, the experimental design, experimental group, and the negative control group. We can make some reasonable statements, and our reasoning is, or our statement is as the oxygen is reacted, the atmospheric pressure will raise the water level in the tube in direct proportion with how much oxygen is removed. So that's our reasoning, right? So that's our reasoning. This is how we're going to come up with our statement. Our statement's going to be whatever percent oxygen we think is in the atmosphere. But our reasoning to how we got to that percent is right here. Now, is the change in the water really because of the oxygen, because oxygen was removed? Could the atmosphere have changed and there be more or less pressure from the outside? Well, the negative control group answers that question. It allows us to make sure that any change that happens in the experimental group is because of the iron and oxygen reacting, not because of some other factor. So this control group is very important. The background has to support the experimental design and help explain the results. Again, that's a summary of this page of notes. And the design includes the apparatus, the setup, the experimental group versus the control group, and the reasoning. All the reasoning just determines the apparatus, control, the experimental group, and the negative and positive control. All right, so that's it for the concept map of this experiment.